Welcome for this lecture. Today we are going to discuss initial and final value theorem. Initial value theorem is used to find out the initial value of the system, that is x of 0. Similarly, final value theorem gives us to find out the x of infinity, that is the final value of the system, directly by Laplace transformation. Okay, we'll see one by one. Initial value theorem. Initial value theorem, as we said, it allows us to find out the initial value, that is x of 0, directly from Laplace transformation, that is x of s. If x of t is a causal signal, okay, if x of t is the causal signal, what do you mean by this causal? Definition of causal is if x of t signal will be equal to 0 when t is less than 0. So if you are taking this, t less than 0 comes here. T is less than 0. Here your signal should be 0. That is your causal signal. Now we'll define, then if x of t is a causal signal, then we can say that x of 0 will be equal to limit of s into x of s, where s tends to infinity. This is the theorem of initial value. Okay. Now we'll prove this. To prove this theorem, we use a time differentiation, that is time differentiation property. We use time differentiation property, that is Laplace transformation of differentiation signal, that is dx of t divided by dt will be equal to s x of s minus x of 0. Okay, this is the property of the differentiation signal. If you use the formula, then it will be integration of 0 to infinity dx of t by dt into e raised to minus st into dt. So in the place of x of t, we have substituted dx of t by dt into e raised to minus st into dt. Now, if you would like to find out this initial value, then this term, what we can say is 0 to infinity dx of t by dt into e raised to minus st dt. Right hand side will equate both, that is s into x of s minus x of 0 will be equal to this term. So in this equation, at the right hand side of this equation, if we let s is equal to infinity, okay, in this right hand side, if we let s is equal to infinity, then in this term e raised to minus st, where we have s, here we not have s, here only we have s. If you allow to tend s is equal to infinity, that is e raised to minus st, then this term goes to 0. When this term goes to 0, then this entire term comes to 0. Therefore, what we can say is limit of s of into x of s minus x of 0, where s tends to infinity, will be equal to 0. Therefore, so s tends to 0, there is no s over here. Therefore, this x of 0 can be sent this side. Therefore, we can write x of 0 will be equal to limit of s into x of s, where s tends to infinity. Okay, where s tends to infinity. So this is the initial value theorem. You remember, to find out initial value, we have to substitute s is equal to, means s tends to infinity, that is s is equal to infinity in the system. Okay, then similarly we'll find out the final value theorem, that as we said, we are going to find out the x of infinity, that is the final value of the system, directly by Laplace transformation, that is x of s. As we said, if x of t is a causal signal, if it is a causal signal, then limit of x of t, where t tends to infinity, will be equal to limit of x of s, where s tends to 0. Okay, that is, to find out this, x of infinity will be equal to limit of s of x of s, where s tends to 0. This is the theorem of a final value. Now we can find out, we'll see the proof of this. As we said, Laplace transformation Laplace transformations of a differentiation signal will be is nothing but s into x of s minus x of 0. Okay, if you are writing equation, then it will be 0 to infinity x of t. In the place of x of t, we are going to write dx of t divided by dt equal to s into x of s minus x of 0 as it is. Okay, according to this is according to formula, this is into e raised to minus st into dt equal to s x of s minus 0 x of 0. So we will take this part, that is into that is a formula part, 0 to infinity dx of t by dt into e raised to minus st into dt. So and here we have x of s minus s into x of s minus x of 0. Both the sides will apply limit where s tends to 0. We'll write apply limit on both the sides where we had a signal s x of s minus x of 0. This is equal to 0 to infinity dx of t by dt into e raised to minus st into dt. For this, both the sides we have to apply limit where s tends to 0. So for this also limit where s tends to 0. Now we'll take a right hand side of this, that is limit of integration of 0 to infinity dx of t by dt into e raised to minus st into dt where s tends to 0. Only right hand side we are taking. We will compare this one with left hand side later. Okay. Now in this case, limit will take inside the integration, since in this integration part only integration dx by dt is with respect to t. Okay, where s comes only with respect to this e. Therefore we'll write only right hand side. Okay, so this will be limit of we'll take integration of 0 to infinity dx of t by dt into dt. Okay, and then limit will take inside, that is limit of e raised to minus st where s tends to 0. Now only right hand side we have taken. Tell me, so if you are substituting limit where s is equal to 0 in this part, then this one will be, when you substitute 0 here, it will be e raised to 0. What is the value of e raised to 0 is 1. Then this integration of 0 to infinity dx of t by dt, it cancel, and then into 1. So when you have integration and a differentiation get cancel, it will be x of t. Substitute the limits of upper limit and lower limit. So first substitute upper limit, that is x of infinity, minus lower limit is x of 0. This is your RHS. Now compare both LHS and RHS, means write both the sides of this. It will be limit of s into x of s minus x of 0 is the left hand side where s tends to 0, which is equal to x of infinity minus x of 0 at right hand side. Now so if you write this, x of 0 and this get cancelled because x of 0 is independent where there is no s. So here there is no need of substituting s equal to 0. So this minus x of 0 and minus x of 0 get cancelled. Therefore x of infinity will be equal to a limit of s into x of s where s tends to 0. So you can find out the final value by substituting s is equal to 0. Now we can conclude that in a final value, to find out x of infinity, we have to substitute s is equal to 0, and for initial value theorem, to find out x of 0, we have to substitute in the function s is equal to infinity. Okay, so these two are your final value and initial value theorems. Now we will solve few numericals on this. So that is we'll see, take this examples. Find the initial value of f of s is equal to s plus 1 divided by s plus 1 whole square plus 3 square. Remember, to find out the initial value, that is x of 0, Okay, or you can say here f is there, so it will be f of 0. It will be equal to, what is the formula? Limit of s into since f of 0, it will be limit of s into f of s, where s tends to infinity. Okay, this is the theorem. Okay, f of 0, if you would like to calculate initial value, then it will be limit of s into f of s, where s tends to infinity. So now we will take to find out this f of 0, limit s we have to write. Okay, and then f of s is, right, s plus 1 divided by s plus 1 whole square plus 3 square, where s tends to infinity. Don't substitute directly infinity over here. When you substitute infinity, so this is infinity plus 1, again infinity, this is infinity plus 1 whole square infinity, and then here plus 3, again infinity by infinity will be undetermined. So that you don't go for. Whenever you are substituting s is equal to infinity, make sure that all the terms in the entire, in this function, you have to get s terms as 1 by s. Okay, it means s terms should comes in the denominator. Why it has to come in the denominator? Because 1 divided, because you are going to substitute s is equal to infinity, then 1 divided by infinity goes to 0. Okay, make sure that you are getting in this form. Okay, then we have to simplify. Don't directly substitute s into f of s, s is equal to infinity. Okay, don't substitute like this. Simplify this. That is, f of s can be written as, okay, limit of s tends to infinity. Okay, where s was there, here what we will do is s plus 1 is there, s plus 1 divided by s plus 1 whole square plus 3 square. From this part, take s outside, that is s square. Okay, s we have taken out, then it will be 1 plus 1 by s in the numerator, divided by, here also you take a s outside, that is s plus 1 whole square is there. To take s square outside, then it will be 1 plus 1 by s whole square plus 3 by s whole square. Okay, now we can substitute, this is equal to limit of s tends to infinity. So s square get cancelled, only terms is this remains, that is 1 plus 1 by s divided by 1 plus 1 by s whole square plus 3 by s whole square remains. Now you substitute s is equal to infinity in all the factors. That is 1 plus 1 divided by infinity, 1 plus 1 divided by infinity whole square plus 3 by infinity whole square. So what is the term? 1 plus 1 divided by infinity is 0, divided by 1 plus 1 by infinity is 0. So 1 plus 0 is 1 square, so it is, which is 1, plus 3 by infinity is 0, 0 square is 0. Therefore, what you can write is, it is 1 plus 0 is 1, 1 plus 0 is also 1, 1 by 1 is 1. So now limit, that is f of 0 will be 1 by substituting limit of s into f of s, where s tends to infinity. Make sure whenever you are substituting s is equal to infinity, your factors should be of 1 divided by s form. Then we will see another example, that is find the final value of x of s, which is equal to 10 divided by s plus 1 whole square plus 10 square. Remember, here we are going to substitute final value, that is x of infinity, which is equal to a limit of s into x of s, where s tends to 0. Whenever you are substituting s is equal to 0, directly we can substitute 0, because 0 into x of s, anything it will be zeros, so directly you can substitute. That is, in this case, f of infinity, sorry, here we have x of s, so x of infinity we supposed to find out. It will be limit of s into x of s will be 10 divided by s plus 1 whole square plus 10 square, where s tends to 0. When you substitute s is equal to 0 in the first itself, entire terms goes to 0. So therefore x of infinity will be 0. Remember one thing, final value we cannot, final value theorem, by using final value theorem, final value we cannot find out directly. We have to go through the poles and all. We'll explain now, okay, by taking one example of this. Let's take a next example. Find the initial and final value of f of t, where f of s is 60 divided by s square minus 2s plus 1. Now, to calculate initial value, there is no problem for us to do. We have a formula, that is, first we'll take initial value that is f of 0 of the signal, which is equal to limit of s into f of s, where s tends to infinity. So bit simplification we have to do here, that is s limit of s tends to infinity will write here s 60 divided by s square will take outside from this. Then when you have taken s square outside, it will be 1 minus 2 by s plus 1 by s. Okay, s 1s and 1s get cancelled, so remaining terms is 60 divided by s into 1 minus 2 by s plus 1 by s square. Substitute s is equal to infinity now. So when you substitute s is equal to infinity, then the term 60 divided by infinity into 1 minus 2 by infinity plus 1 by infinity square. So this term goes to 0, 1 divided by infinity, 2 by infinity terms is also goes to 0, and then remaining is 60 by infinity. So anything divided by infinity, that is, you can write 60 by infinity remains. So anything by infinity will gives you 0. Therefore initial value of this one f of 0 will be 0. Okay, to find out the final value, as we said, while finding out the final value, we should be careful about it, as we said. So this denominator indicates always in the function, okay, always in the function f of s, or it might be x of s. You have a numerator divided by denominator. Remember, the denominator s, how many s's are there, that represents number of poles. Okay, s square minus 2s plus 1 gives us s. How many s's are there? 2 s's are there. Then we have to find out those s values. What is the value of s values? Those values are represents your poles. So those poles should be, that is, value of s or roots of s should lie right hand side of the s plane. If this is entirely s plane, then your roots of s, okay, your roots of s should lie, if it is lying right hand side of the right hand side of this s plane, then we cannot find out the final value theorem. Okay, or we cannot find out the final value. So this s it should belong to the left hand side, then we can easily find out. Okay, so now to find out f of infinity, simplify this. It will be s into limit of s into f of s, where s tends to 0. So we'll write s into 60 divided by s square minus 2s plus 1. Don't substitute the values directly. What we can do is, we'll write limit of s into 60 divided by s square minus 2s plus 1 will be s minus 1 whole square. Okay, where s tends to 0. In this case, s minus 1 denominator, it is s minus 1 whole square, means s is equal to, there are two roots, 1 and 1. Both are positive. Therefore, since both the poles of f of s, lies to a right side of the s plane, so final value theorem cannot be found out. Okay, so this means final value cannot be, to find out this final value, we cannot apply final value theorem. Okay, therefore we cannot do it. So we can write the sentence over here. Okay, now we'll discuss the Laplace transformation, inverse Laplace transformations. So Laplace transformation of e raised to minus at into u of t, when you have calculated, it is 1 divided by s plus a. Correct? So like this we used to calculate. So Laplace transformation of e raised to minus at is 1 divided by s plus a. Now we have to calculate if 1 divided by s plus a is there, its inverse Laplace transformation will be e raised to minus at into u of t. Okay. How we have to calculate? We have a synthetic formula, that is x of t is to calculate inverse Laplace transformation of x of s. We have x of t equal to 1 divided by 2 pi integration of sigma minus j infinity to sigma plus j infinity into x of s into e raised to plus st into dt. Okay, so it will be ds, okay, with respect to s. Now, but since it is complex and it is difficult to deal with this, so what we are going to do is we are going to use the method called partial fraction. Okay, we use the method partial fraction, which gives us, it should be of a pure factorial form, saying ki p of s by q of s should be expressed as a factors. And to apply partial fraction, there are some conditions to be followed. First one is x of s must be proper function, okay, proper factorial function, and that is numerator should be less than the denominator. Meaning of this one is, if you say p of s by q of s, here p of s is the numerator and q of s is the denominator. A denominator s degree, okay, s degree of a numerator should be less than s degree of denominator. Okay, it means s degree should be less in the numerator divided by as compared to your denominator. Okay, if not, suppose if it is s square plus s cube, it holds good, because numerator degree of s is 2, which is less than 3. Okay, but if it is like s cube by s square, then what we have to do is we have to use a long division method, and then we have to go for we have to reduce that, and then we have to use for partial fraction method. And q of s, second condition is q of s should be factored form. Okay, this should have a proper factorials. We'll see example for this. First example, find the inverse Laplace transformation of x of s, which is equal to 2s plus 4 divided by s square plus 4s plus 3. Okay, to do this, x of s should be equal to 2s plus 4, and check first condition, degree of the numerator is 1. Is this less than degree of a denominator? Yes, it holds good. So next we have to go for a second condition, that is x of s should have denominator should have, that is q of s should be factorial. So we'll write that 2s plus 4, is this s square plus 4s plus 3 can be written in the form of factorials? Yes, we can write. Take a calci, s square plus 4s plus 3 you can do in the degree to solve the equations, then get what is the value of s over here. S will be minus 1 and minus 3. Therefore factors of this one denominator is, we can write s plus 1 and s plus 3. Okay, so this can be written, or you would have remembered this s square plus 4s plus 3. Remember, multiplication of these two should be equal to addition of these two. So that is nothing but multiplication is 3, addition is 4. How we can write addition of 4 equal to multiplication of 3 is nothing but 3 into 1. If you multiply 3 into 1, it will be equal to 3. If you add these two factors, that is 3 plus 1, you will get a 4. So therefore one root is s plus 3, another root is s plus 1. Like this also you can do. It will be 2s plus 4 divided by s plus 3 into s plus 1. Use a partial fraction, then you can write this entire equation, like 2s plus 4 divided by s plus 3 into s plus 1 will be written as, by taking two variables, a divided by first factor plus b divided by one more factor. Okay, now cross multiply this and then find out a and b. To find out that a and b, 2s plus 4 divided by s plus 1, s plus 3 will be equal to a into s plus 3, sorry, cross multiplication, s plus 1 plus b into s plus 3 divided by s plus 1 into s plus 3. Okay, so these two get cancelled. So we will be having 2s plus 4 equal to a into s plus 1 plus b into s plus 3. We can, you may have s plus 3 here and s plus 1 here, not a problem. Okay, so in this equation 2s plus 4 equal to a of s plus 1 plus b of s plus 3. In this equation, put value of s equal to in such a way that b should be 0. To make b should be 0 and to calculate what is the value of a, okay, what value we supposed to substitute s equal to make this b equal to 0. So if we substitute s is equal to minus 3 in this, so minus 3 plus 3 will be 0, then b will be 0. So put minus 3 in this entire equation to calculate a also. Therefore entire equation you have to substitute wherever you have s minus 3, that is 2 into minus 3 plus 4 equal to a of minus 3 plus 1 and b will be 0. Okay, simplify this. If you substitute here, it is minus 6 plus 4, which is nothing but minus 2, equal to a of minus 2. Then a will be equal to minus 2 get cancelled, a will be equal to 1. Similarly, in this equation 2s plus 4 equal to a of s plus 1 plus b of s plus 3. In this equation, to calculate a value, sorry, to calculate b value, and we have to make a value equal to 0, what value of s we have to substitute. So if you substitute a equal to minus, sorry, s is equal to minus 1, then a term will be 0. Then substitute s is equal to minus 1 in this entire equation. Then it will be minus 2. Okay, 2 into minus 1 will be minus 2 plus 4 will be equal to 0 plus minus 1. If you substitute here, it will be minus 1 plus 3 is 2. Okay, then minus 2 plus 2 is 2 equal to 2b. 2 get cancelled, therefore b will be equal to 1. We have got a equal to 1 as well as b equal to 1. Therefore use that is a divided by, which was that, a divided by s plus 3, then 1 divided by s plus 3, because now we are substituting a value as 1, and then b value is also 1 divided by s plus 1. So now we have to take, after this, apply inverse Laplace transformation, 1 divided by s plus 3 and 1 divided by s plus a. Recall once, what is the Laplace transformation of e raised to minus 18 into u of t? What was the Laplace transformation of e raised to minus 18 to u of t? Is nothing but 1 divided by s plus a. Okay, its Laplace transformation was 1 divided by s plus a. Is this in the form 1 divided by s plus a, and this is also in the form of s plus a. Therefore inverse Laplace transformation of these two terms will be equal to, it is nothing but e raised to, in the place of a we have 3, that is minus 3t, okay, and which is minus 3t u of t plus 1 divided by s plus a, 1 plus s plus 1, in a value is 1, therefore it is e raised to minus 1t into u of t. So therefore inverse Laplace transformation will be e raised to minus 3t plus e raised to minus t, then u of t you can take outside. So this is x of t, where x of s is this, and when you take inverse Laplace transformation, x of t is this one. X of t is equal to e raised to minus 3t plus e raised to minus t u of t. So we will deal with another one. example, which is f of s is equal to s plus 1 divided by s square plus 4s plus 13. So to deal with this, don't go for directly s square plus 4s plus 13. Remember the numerator, that is s plus 1. Whenever you have such cases like s plus 1, s plus 2 or whatever, you make use of cos and sine t's, that is those functions. Cos functions Laplace transformation and sine functions Laplace transformations. So if we use those things, it will be easy for us. So recall once, cos of Laplace transformation of cos at is equal to, it is nothing but s plus 1 divided by s plus s square plus, Laplace transformation of cos at is equal to s divided by s square plus a square. Okay, and then Laplace transformation of sine at is 1 divided by, it was s square plus a square. Okay, similarly we can make use of this thing, and Laplace transformation of e raised to minus at cos bt. What is the formula for this? Minus e raised to minus at cos bt is Laplace transformation of this function is nothing but s plus a divided by s plus a whole square plus b square. Okay, make use of these formulas and then bring in this entire equation in that form. That is s plus 1 as it is you keep in the numerator, but the denominator part we have to get in the form of s plus 2. So s plus 1 divided by, I'll write, let's see, s square plus 4s plus 13 can be written as 4 plus 9. When you practice much, you will come to know this. Okay, then what about this? Keep s numerator as it is, s plus 1, s square plus 4s plus 4 plus 13. So you just observe this, that is s square plus 4s plus 4 is nothing but s square plus 2 into 2s plus 2 square. Okay, is this a square plus 2ab into b square. A is s, okay, a is s, b is 2, 2ab is this. Okay, so we can write this equation as s plus 1 divided by s plus a whole square plus 9 was there. Okay, now we can write s plus 1, s plus a whole square is nothing but a is 2 here, s plus 2 whole square plus 9. 9 can be written as 3 square. Now observe, numerator is different and denominator is different. So to make this s plus 1 and s plus 2 same, so I'll add plus 1 and minus 1 in the numerator. Nothing is going to change. Plus 1 minus 1. So therefore to write this, it will be s plus 2 minus 1 divided by s plus 2 whole square plus 3 square. Okay, you can take s plus 2 minus 1 divided by s plus 2 whole square plus 3 square. Okay, this entire equation, once you have written like this, that is s plus 2 minus 1 whole divided by s plus 2 whole square plus 3 square. Okay, now take this, there are two factors in the numerator and this denominator is common for both. So this equation can be written as s plus 2 divided by s plus 2 whole square plus 3 square and minus 1 divided by s plus 2 whole square plus 3 square. Okay, now we'll make use of the Laplace transformation of that, as we have discussed. Laplace transformation of e raised to minus bt or minus at, anything you can take, sine at will be equal to a divided by s plus s plus b, okay, square plus a square. Similarly, Laplace transformation of e raised to minus bt cos at is s plus b divided by s plus b whole square plus a square. Okay. Now we'll compare those two. Cos is not a problem for us because the first factor, which is s plus 2 divided by s plus 2 whole square plus 3 square. Okay, so this Laplace inverse Laplace transformation, if you are taking, it is nothing but similar to as that of your cos, that is e raised to minus bt cos at formula. Okay, so then directly you can write this. It is nothing, inverse Laplace transformation of this factor is e raised to minus 2t cos 3t. b is 2, a is 3. Okay, but second factor, which is minus 1 divided by s plus 2 whole square plus 3 square was there. Okay, 1 plus 3 square was there. When you are applying for this with respect to a sign, there is sign, sorry, e raised to minus bt sin at's formula is, e raised to minus at sin formula is a divided by s plus b whole square plus a square. So here we have 1 divided by this. Okay, what we can do for this one is we can multiply and divide it by 3 because a we require. In this case, compare this factor and only second factor. So a is 1, here a is 3. So to mention that, we have to multiply and divide it by 3. When you multiply and divide by 3, it remains 1. You can take this factor, which was 1 divided by s plus 2 whole square plus 3 square was there. We make a equal to 3 here. So to make 3 here, we have to divide it by 3. Okay, multiply and divide it by 3. So now 1 by 3 into 3 divided by s plus 2 square plus 3 square. Now it is in this form. Therefore, 1 minus 1 by 3 minus 1 by 3, okay, minus 1 by 3 e raised to minus 2t into sin 3t we can take. This is the inverse Laplace transformation of the signal x of s, which is equal to 2s plus 4 divided by s square plus 4s plus 3.